Welcome to ClickMyProject.com. Now we're going to discuss about the project performance enhancement of skin cancer classification using computer vision. Now we're going to discuss about the abstract of the process. Skin cancer detection using the computer vision involves the application of advanced image analysis algorithms to automatically identify and classify the type of the skin lesions, potentially the cancerous, from digital images or else from the photographs. By machine learning techniques and then the deep learning networks, this technology can assist the healthcare professionals in early diagnosis, improve the chances of successful treatment, and reducing the burden on the healthcare systems. Detecting the skin cancers at an early stage is challenging for dermatologists, as well as in recent years both supervised as well as the unsupervised learning tasks have been made extensive use of the deep learning methods. One of these modules, by using the convolutional neural network, that is the CNN, has involved in this project for the object detections and classification test. So hence in this process the object will be considered as an skin cancerous. So we have basically two kinds of images will be there. One is the skin cancerous image and then the another one is the normal image. In case of any skin cancerous image is given as an input, it should be segmented, then the features will be extracted from the cancerous portion and it will be classified which kind of disease is that, for example whether it is a benign type or malignant type. Finally, the performance of the process will be evaluated by means of the accuracy. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the following steps like input image, pre-processing, feature extraction, classification, then finally performance estimation. These are the 5 modules presented in this project. At first, the input image is taken from the dataset images. The dataset images consist of lots and lots of images which is having the several kinds of skin cancerous portion. After getting any one image from the dataset, the pre-processing will be carried out. In this pre-processing, the image will be resized. The reason for the image resize in the sense, for example, if I am importing the large amount of images which is having the huge size of images, in the sense it will take too much of the time to the execution. In case of low resolution, in the sense it will take the low time of the execution, but the quality of the image will be degraded. That is why we are doing the image resize to maintain the optimum size of the image. After doing the image resize, we just doing the feature extraction. So the feature will be extracted from the images based on the convolutional neural network algorithm. This is belongs to the deep learning algorithm. So here we are applying the deep learning to extract the feature from the images. Before that, the feature extraction means the collection of data from the images. Here the texture kind of data will be extracted from the image. After doing the feature extraction, the test feature will be generated. By previously the train feature also be generated. Now the classification will be applied by means of the machine learning algorithm. So in this machine learning algorithm, we have to classify the input images disease or normal. Whether it is a disease type, in the sense it will be classified as type 1 disease, type 2 disease, type 3, whatever it is. So for example, benign or malignant. So we have to classify these things. After doing the machine learning by means of the classification, we just move to the final stage of the project, that is the performance estimations. So in this performance estimations, we have some performance parameters like accuracy, sensitivity and specificity. Based on this performance estimations, we have to evaluate the overall accuracy and then the efficiency of the classification. Now we are going to discuss about the running procedure of the process. At first, open the spider 3.7 and then change the current directory like this. After changing the current directory like this, you can see the main file.py. Once you open the main file.py, the coding part will be open. In that you can see the run button here. So we have to click the run button here. In the sense the process will be done automatically one by one. First of all, the image will be fetched from the data set. So basically we have two kinds of folders will be there. One is belongs to the benign type and then the another one is belongs to the melanoma type. So first of all, the total number of images will be calculated here, then the training amount of images will be calculated here, then the validation and testing will be calculated here for the benign type alone. As well as for melanoma type, we have to classify the total number of images, training, validation, and testing images. After estimating this thing, we have to segregate the data into a testing, training. So everything we have to do the convolutional neural network, that is the belongs to the deep learning algorithm. So we have applying the convolutional neural network. So finally we have to find whether the total number of images belongs to the second classes, total number of images belongs to the first classes. Then finally we have to execute the convolutional neural network based on the epochs. Here we have around the 100 epochs will be there, so the epochs will be executed one by one simultaneously. The loss values as well as the accuracy of each and every epochs will be calculated. So it will take some time to the execution, because the reason is totally 100 epochs will be there. Here the around 97 iterations will be completed. After completing the iterations, everything, the loss value and then the accuracy will be displayed here. Simultaneously one folder will be open. In that folder we have to change the directory like this. So that we have to open the dataset. Here we can see the two kinds of folders will be there, like melanoma and benign type. So we have to select any one image from the dataset. After the selection of the image from the dataset, the corresponding user input image will be shown in the console, as well as the type of the disease will be shown here. Here the type of the disease is melanoma. Then the accuracy of the overall validation part will be evaluated. Before that, I just explain you the graph here. So this is the accuracy graph, this is the loss value graph. So as usual, the iteration will be started for the execution of the overall accuracy of the process. Now the epochs was completed. Now the evaluation was started for the generating the accuracy of the melanoma category as well as the benign category. You can see the difference between the benign category accuracy, that is the precision, recall and F score, as well as the melanoma category of precision, recall and F score. Finally the sensitivity value is around 90%. Confusion matrix and training and loss of the validations will be evaluated here.